C3.3.7, day 3. We're going to teach you guys the two special cases when solving systems. Okay? Guess besides your notes, guys, get two more things out. Get your green cheat sheet. First period used that green cheat sheet, and they started graphing. Just because they were able to refer to something, help them out. Straight edge out as well. Obviously, you use straight edge to graph this stuff. I'm listening, Harrison.
Could you do this broadcast for 8 hours? Or video for 8 hours?
Good. I don't think I have any lessons that are 8 hours long now.
Can you teach me for 8 hours?
No. You can't pay attention for more than 6. Ooh. Alright. So we have two here, and we're going to graph them on the same plane. And there's one you guys already know. Okay, this is the one that intersects in one equal point. Someone raise their hand and refresh our memory. What form are those equations in right now? Like, which way should you be going to graph them? That'll count.
Slope-intercept.
They're in slope-intercept form. Everybody say that.
Slope-intercept form.
Okay. When they're in, that is basically when they are solved for y. And if you can solve for y quickly, and we're gonna have some like that in a minute.
Mr. P,
Yo,
do you know what one of my children did?
one of your children. Can you say it in front of
They
everybody?
went on your website and watched your video and printed out your notes and everything when they were absent yesterday.
And did they do good on their homework?
Well, she's going to grade it right now, but still, isn't that awesome? Isn't that what everybody should do?
Okay, we're taking right now, so.
Oh, bye.
Miss Pearl really doesn't care that we're taking right now. Okay. All right, back to where we were at. I forgot. I lost my train of thought. Somebody.
Slope-intercept form.
Thank you. So these are in slope-intercept form. Whenever you can get them into slope-intercept form easily, or if they already are, like these two, you definitely want to graph. Use your green cheat sheet. You want to graph them using the slope and the y-intercept. Okay? Practice, practice, practice. You will get good at this. So for the first equation, somebody raise their hand and give me both the slope and the b for this first equation. Callie Christie. Yeah, the slope is 1 and the y-intercept is -1. And then I would graph that line now instead of going to the other one. Let's do one whole line first, and then we'll do the second one later. So our y-intercept is -1, so we put a big old point on the y-axis at -1. And then the slope is 1, so how do I get more points from there using a slope of 1? Trace?
You go to the right one.
No,
You
definitely
go
not.
up one and right one.
Yeah, you go up 1 first because it means 1 over 1, so we're going to go up 1, right 1, up 1, right 1, up 1, right 1. Or we could go down 1 and left 1, right? Doesn't that make a positive 1 slope?
Mm-hmm.
Okay, use your straight edge. I'm getting pretty good at drawing lines freehand, people. Okay. There's the first line. Now, start all over. Go to the second line, jot down the same information, and graph it. Catherine,
I have a question.
talk to me.
So if B is negative and then M is positive, it would be a positive slope?
It'd be what?
A positive slope?
Well, the slope, yeah, again, the slope is
So
positive.
it doesn't matter if B is negative?
No, the b and the slope have nothing to do with each other. I think that's where you're confused about, right? They got nothing to do with each other. Catherine, what's the slope and the y-intercept of the second line? B is -2. Okay? Just a coincidence, guys, that they were kind of like the same numbers for both of them, but they were the opposite of each other. Okay? Penny, question.
So B is just a point on the slope?
Not on the slope, on the graph.
Oh, yeah, that's it.
Yes. Guys, don't make this any more difficult than it is. What Ms. Henning said there is really smart. So B is just a point that's on the graph? Yes. So, graph -2. And then, how do I get more points using a slope of 2? Henning,
Go up 2 over 1
which way over?
to the right.
Yeah. Up 2, right 1, boom!
Bam, right there.
And then you hope that your second line jumps right on top of the first line somewhere. And it did in our first movement. Or I could have gone down 2 and left 1, but whatever. Circle the point of intersection. What is that? What's the coordinates of that point? Where do those two lines intersect? Okay. Pedal cow, what do you think?
1, 0.
1, 0. Remember, a point, guys, is x comma y. It seems like some people are getting points and slope confused. Okay, there's nothing to do between the slope and the point that's the same. The slope is change in y over change in x. A point is x comma y. So, guys, that's what happens 95% of the time. Everybody put your arms up in the air like what happens. This is what happens 95% of the time. And the solution is the point of intersection. Okay? When is there a no solution?
Parallel.
Okay, everybody put your arms parallelly. I love saying that word.
Parallelly.
Parallelly. But don't put them straight up and down. Get a slope on them.
What if they're like this?
Nah, we're going to deal with that one later. Okay? So, let's do this next problem. Okay? Graph the equations below on the same coordinate plane. Okay? You don't have to label it by its letter. I don't care about that. And then let's find the solution. The first line. Okay? Everybody agrees in slope intercept form?
Correct.
Look at the second line. What form is it in?
Standard.
Standard. Very good. That's good if you know that. We're going to graph the second one by using the x and y intercepts. But let's deal with the first one first. Okay? M equals A equals. Okay? Devin, what's the slope of that first line?
2 over 1.
And what is the y-intercept?
1.
Awesome. And some kids, I like when they make it the slope is 2 over 1. You could just write 2, but it's the same thing. So I'm going to do a y-intercept of positive 1. And then, Dev, how do I get more points using a slope of 2?
Up 2 over 1 to the right.
Excellent. Do that a couple times. I'm going to go back and do the down and left thingy.
How many points do you need?
Over 3.
Not over 3.
Or 3 and above.
There's no set rule. That's a really good question, Angie. There's no set rule. I'm just hoping that second line hits the first line on one of those points. We'll see what happens. All right, let's refresh everybody's memory on finding x and y intercepts. That's where we're going to go. 2 points with zeros in the middle, and we're going to take the 0 and plug it in for y, because that's the y value of the point. So we started calling it last period, guys, the cover-up method. Kids liked it. When y is 0, do you guys agree it just goes away?
Yeah.
Cover it up. Cover it up. And so it's gone. I'm going to go 2x equals 4. Divide both sides by 2. How many people got x be 2 when y is 0?
Me.
Plug that into your point. There's the x-intercept. Now, start all over and put 0 in for x and cover up the x's. Okay? So I'm going to cover this up. So that means negative y equals 4, but I don't want to know what negative y equals. I want to know what positive y equals. We divide both sides by negative 1. So how many people got y to be negative 4? Okay? Those are the x and the y intercepts. Let's graph those 2 points now. So 2, 0. There's 2 units to the right of the origin. 0, negative 4 is down here. Okay? Use your straight edge. Let's see. Go like this. Ooh. How many people got lines that are parallel? That appear to be parallel. When will they intersect? So what do we? Okay. So what do we know is special about them? They are parallel. And who remembers? How do we write the answer? Colin? Yeah, there's no solution. Guys, they're never going to intersect. So let's write the words no. There is no solution to this problem. That happens every once in a while. Okay? So if they are parallel, you write no solution. All right, jump to the back. One other weird thing happens. Okay? Some of you guys have already started to think about this. Okay? This happens a lot. This happens every once in a while. The last thing that's hard to do is every try to put your one arm on top of the other.
Like this.
This is the third thing that happens. Okay? And we're gonna. Okay. Not every equation is in some form. Look at A. It kind of looks like it might be in standard form, but it's not because the y's are first and the x's are second. What I would do, I would, whenever you can, I'm put a big old star up at the top. Solve for y whenever you can easily. Because then it's in slope-intercept form, and I think it's the easiest way to graph. What could I do to both sides to get y by itself on that first equation? Everybody make a decision right now. What would you do to both sides to solve for y? Natalia, let's add an x to both sides. Because minus x plus x makes nothing, and we get our y by itself. So, cross it up. Natalia, what does y equal then?
Y equals 1 plus x
Switch those around. Remember, we always put our x's first.
plus 1.
Yeah, do it x plus 1. Even though 1 plus x is the same thing, but addition has that commutative property, so let's write it down. Does everybody agree now it's in slope-intercept form? Who's got the slope and the y-intercept? Let's go. Lots of hands up. What's the slope and the y-intercept? Jack Muir.
The slope is 1 and then the y-intercept is 1.
Nice. Just a coincidence, they're both the same value. So everybody graph the first line with a y-intercept of 1 and a slope of 1. Boom. Those slopes of 1 are pretty easy because you're just going up 1 and over 1 all the time. Okay. Letter B. Does that look like it's pretty easy to solve for y?
Yeah.
Real easy. Everybody solve that one for y. Donnie Minetti, what would you do to solve for y? Okay. Who knows what to solve for y on letter B? Trace.
Subtract 2 from each side.
Yeah, look at it, Donnie. All we're going to do, we're going to move that 2 over. To do that, I'm going to subtract 2 from both sides because 2 minus 2 makes nothing. Just y equals x plus 1. Ruh-roh.
Oh, they're the same thing.
They're
Oh,
on top of each other.
Hopkins, what's the slope of the y-intercept of the second line?
my pencil away.
Guys, here's the other special case.
How do you draw that?
Watch, watch. It's got a y-intercept of 1 and a slope of 1. Does everybody agree we're just drawing the same, another line on top of the first line? Okay. What's special about these two lines?
They're on top.
Okay. Well, would it be safe to say that they are the same line? Look at it when you're solving for y. Okay. Same line. Not just slope. It's got the same slope and the same y-intercept. So basically it's the same line.
So what would the solution be?
I did a whole lot of that thought, Billy. Glad you're thinking about that. Where do these two lines intersect?
Everywhere.
How many solutions are there?
Infinity.
Guys, you guys are all over it. Here's what you write. Infinitely many solutions. It's kind of like the exact opposite of no solution. No solution. There's infinitely many. There are an infinite amount of points that are the solution to both of these equations because they go on forever. They go on infinitely. So all the points that are on one are also on the other. So you do have to write the words infinitely many solutions.
But
It does go on, but that's not really an answer to the question.
Can you do infinite solutions?
Yes, that's what you write. That makes more sense than just the word infinite.
Teachers and students, pardon the interruption. Students, today we will be going out for recess. It has been a little bit rainy, but you do need to bring your coats because we will be going out for recess from From this point forward, for the remainder of the winter, you will bring your coats down to lunch recess unless otherwise noted. So if there's no announcement, you always bring your coats down. Today we will be outside for recess. Please bring your coats. Thank you.
How many of you guys have a coat in your locker?
I'm wearing it.
I'm wearing mine.
Yeah, I'm wearing mine.
Just for the record, there's about 5 people with their hands up.
Wait, Mr. Pansy.
Bring your coats, it's cold.
Mr. Pansy,
You guys live in Chicago.
It's not that.
Figure it out. Harrison,
can you just write infinite solutions?
infinitely many solutions.
I can just put infinite solutions.
I think I would probably accept that.
Yeah.
Infinite solutions. Because there are an infinite amount of solutions. So I get what you're saying. All right, let's wrap all this up. If the lines intersect, okay, the types of systems here, there's 3 cases. This, and then this. Those are the 3 things that are going to happen. If the lines intersect, how many solutions are there? Everybody put one finger up in the air. If they intersect, there is 1 solution. If the lines are parallel, okay, they have the same what? Oh, we didn't even talk about that yet, did we? What do the parallel lines have the same of?
Same slope.
They have the same slope. And there is no solution. Okay? Parallel lines, guys, have the same slope. Think about that. If the lines are the same, okay, they try to trick you by just giving you the same line twice. There are an infinite number of solutions. Those are the 3 things that could happen. 1 solution, no solution, infinitely many solutions. All right, let's see if we get a couple of these done. You guys got time for your homework.
These are standard form. No.
The first one's in slope intercept. The second one's in not in any form, but we're going to deal with that one in a minute. Let's do the first easy one right off the bat. It's in slope intercept form. Pabon, give me the slope and the y-intercept.
The slope is 2/3 and the y-intercept is 3.
Okay. We got a slope of 2/3 and a v of 3. Does everybody agree with that? Okay. Take your time and graph it. We're going to graph our y-intercept of 3 first. And then, Antonio, how do I get more points using a slope of 2/3?
Up 2, then to the right 3.
Awesome. I'm going to do that a couple times. We're down 2 and left 3. Very good.
Oh.
Okay. There's the first line. Okay. Slope intercept form, guys, should be a layup by now. You guys know what that means? It's in slope intercept form, guys. Let's do this. Let's get it done. This next one, I don't like it. I don't like the form that it's in. 3y equals 2x plus 15. What would you do to make it easier for your life? Henny, what would you do? Let's divide both sides by 3 and put it into slope intercept form. That's what I would do. Whenever you can solve it for y, you can put it in slope intercept form. We haven't done this in a week or 2. Can anybody tell me what the right side's going to say? Look at it carefully. Come on, guys. Oh, I appreciate this. Is good. Connor Coffee.
2/3 x plus 5.
2/3 x plus 5. Excellent, Connor. And then here's how we got that. 2 is not divisible by 3. Okay, so I'm just going to leave it 2/3. But then how'd you get 5, Connor? You're right, but explain.
I divided 50 by
Yeah, you still got to divide your 15 by 3. So it's plus 5. It's in slope intercept form now. Connor, what do you know about that line?
the slope is 2/3 and the y-intercept is b. Or the b is 5.
The y-intercept is 5, and the slope is 2/3. Guys, what do you notice about the slopes? Right? Are the slopes the same? Okay. Different y-intercepts though. 2, 1, 2, 3. 2, 1, 2, 3. 2, 1, 2, 3. Okay, they're kind of really close to each other. Look at that, they're not too far apart. But will they ever intersect?
No.
Because they're parallel.
They look like it.
What do we write as our answer?
No solution.
Everybody say no solution.
No solution.
No solution. Okay? Make sure you write that. Just don't graph it and assume that I know that you mean no solution. You really have to write it and circle it. That's a lot. That's a lot. Okay. Next one. Okay. First one's the slope-intercept form, should be a layup. I think the second equation, if you add 3 to both sides, you'll get that one pretty quickly. Okay. Ms. Vicky, what's the slope of the first line? And the b, or the y-intercept? Nice. We got a slope of 2 and a y-intercept of 1. So I'm going to go 1 and then up 2 over 1, up 2 over 1. Seems like in a lot of these examples we have all positive slopes. I don't know if I like that. Okay? Yeah. Does make it easier. Okay? Back to Donnie and Eddie. What would you do for the second equation to solve it for y? Add 3 to both sides. Nice job, Donnie. Add 3, y equals 2x. What's going to be after that, Don? Nice. What's the slope of the y-intercept, Don?
The slope is 2 and the y-intercept is 1.
Look at the other line, guys. What do you think?
The same.
They're on varying solutions.
Look. They're the same line. Once we solve them for y, they're exactly the same. So I'm going to... Okay, so we're going to put another line on top of the first line. And Angie, how do we write the answer? Infinite. I always wrote infinitely, but infinite would be fine. Infinite many solutions. So that's the one line on top, the same line on top of the first line. Infinitely many solutions. You guys get that or not? You can do this stuff. All right, try the next one.
I see what I did wrong. I did the right one.
What's your question? So this the first line? So we graph this one out. We're y-intercept of 1. And then it's got a slope of 2. Right? You just graph it from this one. Okay. Miss Catherine, what's the slope of that first line here? And the b? -2. Okay? Pretty straightforward. Slope of 3, b of -2. So I'm going to put a big old point on the y-axis, and the y-intercept of -2. Then I'm going to go up 3 and over 1. Again, too many positive slopes today, guys. We're not making you guys think enough yet. Yeah, you're good at not thinking, Angie.
Oh.
All right, there's the green line.
He's directing Angie.
Okay. Manetti, what do you do to the second equation to solve it for y? You can do it. No, definitely not. You want to move it over. You don't want to get rid of. There's no dividing or multiplying right now. We're just going to move. Say add 2x. Say it.
Add 2x.
Where?
To the right side.
To both sides, you knucklehead.
Both sides. That's what I meant.
That's what you meant. Okay. Everybody add 2x to both sides. Tara Henley, what's each side now say? Add 2x.
Y equals
Nice.
3x minus 2.
Okay, slope and y-intercept.
3x and then m equals 3.
M equals 3. Don't. Some of you guys do that. You say that the slope is 3x. There's no x in the slope, just the number in front. Common mistake. Try to get out of that habit. What's the y-intercept?
B equals -2.
Equals -2. Ooh, is that the same as the first one?
Yeah.
Yes, it is.
All right. So look, it's gonna be the same line, one on top of the other. Tara, what do we write as our answer?
Infinitely many solutions.
Nice. Infinitely many solutions. Now, these are just very rare special cases, guys. You're not gonna. Your homework might have a few of them, but the majority of the time they intersect at a point. All right, last one should be a layup. Both of them are in slope-intercept form. You guys are doing great. Give them graph. Tara Burke, what's the slope of the first line? What's the y-intercept? Nice. 3. Slope of 1, guys, get in the habit. That's real easy to graph. Hey, finally a negative slope. Hip hip hooray for the negative slopes.
I know, right?
Okay. Mr. Lance, give me the slope of the y-intercept of that second line.
M is -2 and B is -4.
Okay, graph that. -3 is our y-intercept. Remember, a negative slope, guys, and we want it to cross the green line, so I want to go up and left instead of down and right. If I go down and right, I'm just getting farther away from it. So the slope's, you know, so if I go that, so 2, 1, 2, 1, boom! Okay? You gotta make that sound when you jump on the other line.
Boom!
Boom!
Damn.
Draw your line. And Lance, what is the point of intersection? How do you label that point correctly?
-2,
Comma.
1.
Yeah, negative. How many people got -2, comma 1?
I did.
Okay. Remember, it's x, comma y for points. We've been doing so much slope talk. Okay. When we go back to a point, you got to go x, comma y. So, hey, the last one. This is what happens like 90% of the time.
Wait, what about the word problem?
Okay. We're not gonna do the word problem. Word problems. We're gonna do a word problem unit at the after the test, and then have a little quiz on it.
Good.
Okay.